Hi, how are you all? Welcome to the class. Let's get started with this chapter, that's carbon and its compounds. This will be the first lecture of the series of chemistry that we are going to start. So this is a very important chapter because this is the basics of organic chemistry that you are going to encounter in your grade 11 and grade 12. So please pay attention to this chapter. This will be right from the basics. In today's video, we will be understanding about introduction to carbon. Okay, so here we go. Carbon is a non-metal. In your grade 9, you have already studied that. So carbon belongs to non-metal category. So it's a major constituent of coal. Its symbol is C. Atomic number is 6. That means it has 6 protons in its nucleus and 6 electrons are revolving outside the nucleus. Its electronic configuration, that is distribution of electrons among different shells, is 2 and 4. That means in the first shell, that's K2, 2 electrons are there, and in the second shell, 4 electrons are there. As the last shell is L shell, it is having 4 electrons in it. It means that it is valency is 4. Okay, its valence is 4. Here is the structure of carbon atom. It is having a nucleus in the center, and this nucleus contains 6 protons in it and 6 neutrons, and 6 electrons are revolving outside the nucleus in their respective shells. In first shell, this is K shell, it is having 2 electrons, you can see, and in the last shell, this L shell, it's having 4 electrons in it. Okay, so this is a general description of carbon atom, what it is and where it is placed in the periodic table. Got it? So now moving ahead, we have occurrence of the carbon. How carbon occurs in this nature? Carbon can occur in two different states. One is called a free state, second is called combined state. Free state means where carbon is only present in its pure form or native form. Native form. First, let's understand about free state. There are 3 different free states of carbon or pure states. One is called diamond, graphite, second, and Buckminster fullerene are 3. These are also called as allotropes of carbon. We will discuss that in the coming up classes. So here we are only looking at the occurrence, how it occurs in the nature. It also occurs in the form of combined state, like in the form of carbon dioxide in atmosphere, in the form of fossil fuels, coal, petroleum, natural gas, carbonate and bicarbonate. These are 2 different forms of carbon, bicarbonates. Okay, carbonates means CO3 dinegative, this form. It can be metal carbonate, it can be hydrogen carbonate, or bicarbonate means HCO3 negative. This is hydrogen carbonate or bicarbonate. Clear? So these are some of the forms in which carbon occurs in nature. Let's move ahead. We have discussed about allotropes of carbon. So let's understand first what is the definition of an allotrope. The various physical forms in which an element can exist are called allotropes of element. Okay, so different forms can be there. So if we talk about carbon, carbon is existing in 3 different forms in nature. Let's understand about different types and remember their names. One is graphite, another is Buckminster fullerene, that is C60, C60, and last one is diamond. Okay, so these are the respective structures given. Just have a look. Look at these. These are just layers over layers. This is a football-like structure. It's a ball-like structure, and this is a structure that represents diamond. Now let's understand different properties of diamond and graphite. Diamond is colorless, transparent substance. It's colorless. Diamond is colorless, transparent substance having extraordinary brilliance. Brilliance means that it can reflect light, okay, or it can reflect light internally as well. So there is total internal reflection of light that gives the brilliance to this diamond. Now graphite, you might have seen graphite in your pencil. Okay, so that's present in the pencil lead. Graphite is grayish black, opaque. That means it doesn't allow light to pass through it. It's an opaque substance, grayish black in color. Coming back to diamond, each carbon linked to 4 other neighboring carbon atoms. Okay, look at the structure of diamond over here. Say, for example, if we talk about this carbon, it's connected to carbon number 1 over here, carbon number 2, carbon number 3, carbon number 4. So this is the arrangement for every carbon. This type of bonding exists for every carbon in diamond. Look at this: carbon number 1, carbon number 2, carbon number 3, and carbon number 4 over here. So that means when each carbon is connected to 4 other different carbon atoms, that means carbon being tetravalent, having 4 valency, it can bond with 4 other different atoms as well, 4 other carbon atoms as well, utilizing its valence electron. In case of diamond, all the valence electrons of a carbon atom are utilized. There are no free electrons in the network of diamond. So what does that mean? When there is no free electron, that means diamond is not conducting electricity, bad conductor of electricity. Because in order to conduct electricity throughout a material, it must have free electrons. Okay, so it cannot conduct current. It has rigid three-dimensional structure. It's rigid because of the compact packing of the carbon atoms. It does not conduct electricity because no free electrons are present. It's extremely hard and heavy. So it's having high density, we can say. High density. High density is there. Now look at the graphite, some structures, and structure is given to us. Look at the graphite structure. There are hexagon rings. First of all, look at this. Follow my cursor here, 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 and here. So there are hexagon rings just like this. Just like this, there are hexagon rings. Okay, so each carbon over here is connected to 3 different carbons. Okay, so there are hexagonal rings connected to each other. There are hexagonal rings. Look at this. This is one, okay, continuous layer of hexagon rings. It is connected to the middle hexagonal rings, and then it is connected to a layer at the bottom of the structure. So how they are connected? So they are not connected by any covalent bonds. These rings are connected by a weak force called van der Waals force. So this weak van der Waals force, it allows these rings to slide over one another, and this sliding property of hexagonal rings over one another gives this graphite a very unique property of lubrication. So graphite is a dry lubricant. That's because its layers are able to slide over one another, making it a bit slippery. So it has sheets-like structures formed by hexagonal array. This is a hexagonal array, one over another. It conducts electricity due to the presence of free electrons. Okay, so remember one more thing, that in case of graphite, each carbon is connected to 3 other different carbons. Okay, so each carbon is connected to 3 other different carbons. So that means each carbon is having 1 electron left out of its 4 valence electrons. Okay, so one free electron per carbon is left. So that 1 free electron per carbon makes it a very good conductor, very good conductor of electricity. Okay, and it conducts electricity due to presence of free electrons, and it is soft and light as compared to diamond. Great. Now moving ahead, what are the daily life applications of carbon, these allotropes of carbon? So diamond is used as precious stone in jewelry because of its rareness and uniqueness. And diamond is also used as a cutting tool, cutting of glasses, okay, because of its hardness. A black diamond is used in this cutter. Black diamond is used to cut glass. And use of graphite, you can see graphite has many uses. Look at this picture. This picture suggests that it is used to conduct electricity. These are electrodes used in laboratory. And look at this. These are pencils, but they have graphite tip. So it's used to write. It's also a conductor. Look at these huge conductors, and these are huge electrodes. These are used in factories to conduct electricity through different processes. And it's also used as lubricant that we have discussed about. So graphite is used to make electrodes, pencils, and lubricants. Conductors connected to the batteries, positive terminal is called anode, and to the negative terminal it's called cathode. And substance that are used to reduce friction between moving parts, that's called lubricant. So this is how graphite finds use in many sectors, and it finds many uses in our daily life. Now coming to Buckminster fullerene, or fullerene in simple case, or C60, there are 60 carbons in a fullerene molecule. We can see that This is latest allotrope of carbon discovered very recently. It's having 60 carbons in its structure. It's arranged in a shape of football, and it looks like a geodesic dome designed by US architect Buckminster Fullerene. And Buckminster Fullerene was not any scientist or chemist or any other related to the science field, but he was an architect. When C60 was discovered, it was seen that C60 has the same geostic dome design that was built by the architect Buckminster Fullerene. So in his honor, the molecule was called as fullerene. Okay, then. So we are at the end of the session now. We discussed a bit about introduction to carbon and its occurrence and allotropes of carbon. So if you have any question, please drop that in the chat box. And please, if you find value in my videos, do subscribe to this channel and like the video as well. So we will be meeting in the next one. Till then, keep learning. Bye-bye and take care.